So in the last video I made this Toolpost riser which I fabricated out of plate steel. At the end of that video I asked for a bit of help because I was getting some vibration from the lathe, and having built this riser, it wasn't helping. Now I don't think I explained that very well, because a lot of people seem to think that there was a problem with the riser itself. So what I meant by that was that the vibration and behaviour of the lathe was absolutely no different with the fabricated riser compared to the compound slide, and I was hoping that it would have made a difference, but it didn't. So I was a bit frustrated by that, and I don't think I really expressed the problem properly. So let's start at the beginning. Here is the original compound slide demonstrating the problem. And then here is the fabricated riser demonstrating the problem. As you can see, those two are, or as you can hear in fact, those two behave exactly the same. So if there was any aspect of the material used, the construction, or anything like that, I would expect it to be different. However, got a load of comments with lots of really good suggestions of things to try and figure out what was causing the problem. Sort of by far the most common one was, why didn't I just use a huge lump of steel or cast iron? That's because I don't have a big lump of steel or cast iron. So what I did have was this plate steel, so I used that. I tend to just use what's kicking around. A lot of people didn't seem to like the welded nature of it. Honestly, don't think that's a problem, and if you've seen any of Howell Heavy Engineering, they built a massive welded boring bar holder, which if it's good enough for them, it's good enough for me. So moving on, in order to eliminate as much as possible, people have suggested that it was the tool holder was no good, or that there was play in the cross slide or the saddle, whatever. I took my milling vise, which is a great big lump of cast iron, and used that as a makeshift tool post. Clamped that down to the cross slide. I tightened the saddle completely, locked it off, tightened up the cross slide so that it was actually quite hard to turn, so basically took out as much movement as I could. With the dial indicator, pretty much any direction I tried I was getting sub 10 micron movement, so I was fairly sure that nothing much was moving. And as you can see from this clip, you get exactly the same result. So that pretty much rules out everything saddle related. Basically leaves the spindle. Now, as I said in the previous video, I'd already checked the bearings. They look pretty good. I gave them a bit of a tweak, tighten up. That made no difference either. So then I thought it could be the VFD or the motor. This lathe is unique in that it originally came with a brushed DC motor which burnt out pretty shortly after I got it, and I replaced it with a brushless DC motor which I'm running using this VFD up here. So my theory is that the VFD was hitting its current limit a bit too early or a bit too freely, and essentially what's happening is that when you plunge the tool in, the VFD just sort of cuts the power to the motor very briefly, and then it comes back in again, and then it cuts it, and then it comes back in again, and that's where you end up with that really nasty vibration. The actual frequency is probably just the natural frequency of the entire lathe. So at one point I was thinking maybe it's the frequency that I'm hearing is something to do with the frequency of the inverter, but I'm not sure that's the case now. That said, what I did do was I changed the PWM frequency. I upped it from 16 kHz to 24 kHz, and that seems to have massively alleviated the problem. After that, I then fiddled with a few more settings, and I seem to have found a good set of parameters that makes this work well enough. So now it cuts like this. So I can still induce same vibration in the lathe if I push it too hard. So as people were saying that, that this isn't the heaviest or strongest lathe in the world, which, I'm fully aware of, and this is probably about the limit of what it can do. But I've just eked out a tiny bit more performance just so I can do what I wanted to do with this material. Just a quick comment on tooling. A lot of people suggesting high-speed steel, and so the main reason I use carbide is because I'm lazy. and I'm not very good at sharpening. But I did try high-speed steel a while ago. I tried it again after your suggestions. What I find is that it dulls very, very quickly on this material. I may well use high-speed steel for the finishing cuts on this. Definitely for the roughing, the carbide for me I find works better. The aluminium tools, yes, they work very well. So what I don't like about the aluminium turning tools is in this material you get a long corkscrews of very sharp metal coming off, whereas with the steel ones the chip breaker actually breaks it up. So it does give a better finish, that has to be said, but again, maybe I'll just use that for finishing cuts. Roughing, when you've got a lot of material to remove, I'd rather have a chip breaker doing its thing. So why does the tool holder overhang the cross slide and the riser like that? Why is it not more central? Wouldn't that be better? Yes, it would be better. However, I deliberately designed it like that because the carriage will only go to here, and if I fit my collet chuck, basically it will only just reach the nose of the collet chuck. So some people seem to think I've made a bell because it was a bit hollow. I can assure you it is pretty dead. Sounds pretty dead to me. It's obviously not quite as dead as a piece of cast iron. I'm really not going to win any bell making competitions. So I hope that answered some of the questions, and thank you for watching.